Hello, hello. Today we're going to talk about central tendency and the effects of change. So measures of central tendency are used to describe the middle of a data set. Commonly we talk about mean, median, mode are measures of central tendency. They're talking about the middle of the data. And sometimes we have, when we've been taught or we learn about mean, median, and mode, range is the next thing people talk about, or they include it when you learn about mean, median, and mode. But mean, median, and mode are measures of central tendency. Range is not. Range is a measure of dispersion. So range is not a measure of central tendency. It is a measure of dispersion, or how spread out is the data. So it's talking about spread in the data, not the middle of the data. So keep in mind that range is different. It is not a measure of central tendency. So you should know by now that mean, to find the mean or average, we add the values of a data set. Then we divide by the number of values in the set. To find median, we look for the middle value or the mean of the middle two values in an ordered set of data. Meaning you make the data smallest to largest, you look at the number in the middle. If there's only one number in the middle, then that's your median. If there are two numbers in the middle, you would need to add those two numbers together and divide by 2 to find the median. Mode. The values that occurs most often, most frequently. I think a mode starts with MO, most often, most frequently. A data set may have no mode, one mode, or several modes. And then we have range, which was our measure of dispersion. And it's the difference between the least and greatest values in a data set. So I want you guys to find the mode from the test scores given below. Pause the video here, figure out your answer, and then unpause, see how you did. So when we look over this set of data, there's two numbers that appear the most often. 85 and 90 are both there twice, so we have two modes in this case, 85 and 90. Now an outlier is a value that is either far less than or far greater than the rest of the values in a data set. It's be much higher or much lower than the rest of the data set. And then this outlier can significantly change our measures of central tendency or our range. It could change our mean, median, and mode greatly. It could also change the range. So here's your chance to try one of these. So I want you to take this set of data and I want you to find the mean, median, mode, and range. Write down your answers, be organized with it. Then throw out the outlier. Find the mean, median, mode, and range. Then I want you to make some type of comparison. So we want to analyze. So not just that you found them both, is that you can make some kind of conclusions. What changed on the median? What changed on the mode? What changed on the range? So go through each of your pieces of information and make some type of conclusions. So pause the video here, find those two sets of data, and then make some comparisons. All right, welcome back. So let's go through and find these. So we have without the outlier. So the outlier is 51. This value is much greater than the others. So 51 really stands out. We don't even have anything in the 40s. We have a low 30, but 51 much higher than the rest. So if I throw out that 51, then I'm only looking at 1, 2, 3, 4, 5, 6 pieces of data. So I can take those, add them up, and I get 159. Then I divide by 1, 2, 3, 4, 5, 6. I divide by 6. And I get 26.5 for my mean. And that's the mean without the outlier. Then if I look at the median, I have two numbers in the middle. I want to order from smallest to largest. Since there's 6 pieces of data, I have 2 in the middle. Well, if I add 28, 28, divide by 2, I get 28. So 28 is the median. If it was an odd number of data, there would just be one number there. When you have an even number in your data set, you'll have to add those two numbers together, divide by 2. Then if I'm looking at the mode, I have a 21 that's here twice, and I have a 28 that's here twice. So we have two modes. And then my range is my highest number minus my lowest number. So my highest was 32, my lowest is 21, 32 minus 21. And when I have those ordered from smallest to largest, that makes it really easy to find. I just take the 32 minus 21, and get that I have a range of 11. So these are the 4 data points I have with the outlier thrown out. Well, what do these numbers look like if I include the outlier? So if I have the outlier, my pieces of data now add up to 210, but I'm going to divide by 7 because now I have 7 pieces of data. So 210 divided by 7 gives me a mean, or 30. Remember, mean is the same as saying average. Then to find my median, I now have an odd number. See, I have 3 numbers larger, 3 numbers smaller. 28 is the number for the median, so 28 is the median. Then if I look at the mode, I still have 2 numbers appearing twice. 21 and 28 are still the mode, but my range is different because now I have this really high number. So I have this 51 minus 21, and I get a range of 30. So now that I found these 4 pieces of data, I can go through and make some comparisons. Well, what happened with the mean, median, mode, and range? So the outlier actually increased the median by 3.5 and the range by 19. And it had no effect on the median and the mode. So the median and mode stayed the same. And this is very typical. This is why if you get a 0 on an assignment, it really affects your average because zeros do not average well. So it makes sense that throwing out an outlier or not having that 0 would make your grade much better because outliers do not average well. They tend to have a great effect on the mean. And the more problems like this you'll do, you'll see that outliers always affect your mean because it, by nature, is much higher and much lower. It could affect the mode and the median based on the rest of the data set, though. But you're always going to see outliers affecting your mean. And in this case, also affected your range because you're throwing out a number that's further out or more dispersed than the rest of the data set. So it's not just a matter of calculating mean, median, mode, and range. It's making this kind of statement about the changes that you saw based on removing the outlier. And I hope that helps you guys with looking at the effects of change on central tendency. Have a great day. OUT spells out.